Hello everyone, welcome to the Advanced Circuits Lab. In this lab, I will walk you through the process of signing in to the server to connect to the Cadence, and how will you make a library, how will you export the images, how would you set up a schematic, how would you run a test class and set up a simulation environment, and how would you simulate the circuit. This lab is the first one, so it's more like an introductory lab where I will be teaching you guys the most basic things. We will be looking at the DC operating point analysis, where we will be able to find the node voltages and node currents of a circuit. I'll try to make the things as simplest as possible, and I'll try to cover all the aspects of the lab delivery. So let's quickly have a look. This is when you open your desktop. This is what you get. You have to download for the Windows users, as I've shared the document on how to connect the Cadence server to the Cadence server. I've already told you guys that you'll have to download the Mobile Extreme, download its free version, and download the portable version if you like. All right, once you open the Mobile Extreme, this is where you get, please refer to the document where it's a PDF document that I've already shared in the contents, where it says that how to connect to the Cadence. Right, so in this window we'll go to the session here. Within the session we'll go to SSH. In SSH, the remote host, which we know as genesis.abudhabi.nyu.edu. This is the server name. This is my net ID, and the port here is 4410. All right, we'll say okay. It seems the first time. Okay, accept. All right, I'll be using my email password here to log in. All right, no, I don't want. All right, once it logs in, this is what you're gonna observe in your system, that you will be taken to the home slash your home folder with your net ID. All right, so to log into the Cadence, we'll have to change the directory to its main Cadence server, and then this is the command that you will write the sourcing, and then virtuoso and this is going to start the Cadence. You see, you're gonna see this pop-up window appears, and once it's done, you'll have to go to the tools, go to the library manager, and when you open the library manager, this is what you're going to look at. So I have made this folder already, or a library here, where I'll be placing all the examples and everything. But I'm gonna delete it for you guys now, and I'll make a new one just to show you how to make a library. So just delete it, delete this one. Okay, yes, delete it. All right, so it's deleted now. So you don't have to do it, because you will have something like a test class here. So you will have a test class folder set up for you. If you don't have it, please make a folder which means something, which is meaningful, and then start working all of your circuits within that folder. For the Cadence, please know that do not try to just shut down everything. You have to give Cadence its care. You have to close it properly, or you will lose your Cadence access, and then I will not be able to do anything. There will be no deadline extension because you were not able to log in because you've done some mistakes in Cadence. Please make sure that this is not happening. So once you are in the file, sorry, where? Sorry, here. So I'm already here in the test class. So what I would like to do here is I'll go to the file and new, and as I said, I'll generate a library, the first library, which I'll name as Advanced Circuits here. Okay, right now it is creating my library in this folder, MFS11 and CDS. All right, I don't mind that. I'll say Advanced Circuits underscore 2026. This is my library which I will be making now. I'll say OK, and the system will ask me to attach a technology file. So for that, you will say that attach an existing technology file, say OK, and then from this pop-up window, you will be choosing CDS DevTech library. All right, apply this one, say OK, and you will see that Advanced Circuits 2026 is now created. And once you select this library here, you will go to File, New, Cell View. Within the cell view, I'm going to name it as cell view example 1. All right, this is what schematic is, the type schematic, and open with schematic L. All right, okay. Once you do it, a pop-up window will open where you can make your schematic. All right, that's the way to open a schematic. So what I'm going to do for this lab is this. I will be making an example circuit. Here's the example circuit. This is taken from your book, Engineering Circuit Analysis by Haidt, 9th and 10th edition. Both of them have the same problem, page 122, exercise question number 23. This is the question that I've taken from there. You see V1 and V2. These are the two nodes with V1 and V2, and this is what we have to find out. And as we see that the output at both of these nodes are like at V1 it will be 7 volts, at V2 it will be 12 volt, and power at resistor 2 ohms is 0 watts, while the power at 8 ohms here is 3.125 watts. So we're going to confirm all these values. These are the answers. All right, so we'll draw this. For this we need 1, 2, 3, 4 resistors, 2 current sources, and 2 voltage sources. So I picked up this problem because this has nearly everything, like voltage sources and the current sources. And you see the voltage sources reverse. So this is minus and plus, and this is minus and plus, where 2 pluses are joined. So it has all the orientations in it. So resistors are are distributed over the network. So this is what we are going to do. We're going to make this circuit, and before that, let me tell you guys that in Cadence, when you want to set up anything, a voltage source, a ground, all this creating elements, it has a special name, which is not actually a special name. We normally use it in the other fields, so we call it as instantiation. So when we say instantiate a component, then we say that instantiating. All right, so for that, let me go to the schematic here. So I want to instantiate a resistor first of all. All right, so to instantiate a resistor, within this window I'll hit the I key, which is from instantiate. So I'll hit the I key, and this window is going to open. So it says that you want to add an instance. All right, yes, I want to add an instance and I want to instantiate. So from the library, you have different ways to do it. So for example, I go to the browse, and from the browse you will look into the analog library. So here's the analog library. Analog library is something that you will be using for most of the labs in this semester. There will be AHDL library too, but we will be working with analog library. Within the analog library, you would like to search for a resistor. All right, so I'll click resistor. You see RES came here, and when you see it here, you can see its symbol actually here, which I cannot see right now. Okay, maybe it needs to be a little bit bigger. Okay, so normally you will be able to view here, yeah, symbol, spectre symbol, and all those things. So you have to click one. This is a resistor symbol that you would like to search for. I'll just close this window, and this resistance, when you clicked it from here, it's already selected. For analog library, cell name is resistor, view is symbol. Right now I'll just close it. So my resistor is still here attached to my mouse. All right, so there were 3 resistors in this combination. So what I'm going to do, this resistor, and then to rotate the resistor, I'll just hit the R key. R key means rotate. All right, so there was a second resistor over here, and there was a third resistor over here. There was a 4th resistor somewhere over here. I'll take a look again. All right, So that's my third resistor. Once you're done connecting the resistors, you'll hit the escape key and you will exit. But I know my fourth resistor was somewhere here, so I'll just put it here. Okay, I can put it anywhere. I can drag it later, so I'll hit the escape key. All right, now let's go to the other components. So we were with this resistor, we have a 2 ampere current source, and then we have another 5 ampere current, half an ampere current source, which is in parallel. I'm just looking at the schematic and the statics of the schematic, so that's why I'm trying to remember that where half ampere source goes. And then we have the voltage source and voltage source. All right, so first of all, let's bring the voltage sources, which is a natural way of doing it. So I will now instantiate a voltage source. So for that, again, hit the I key, you will instantiate. As I said, in analog libraries, what you will be working with. So instead of browse, you can just you can go to browse and select it, or I would like to choose the cell here. So for the voltage source, I'll say VDC, which means direct current voltage source. All right. Yes, VDC is searched here. You have selected. Okay, once VDC is selected, symbol, you won't see the symbol here. To get the symbol updated, all you have to do is to click somewhere on the window. So normally I click at the names. So I'll just click it and you see the voltage source has now appeared. All right. Once it is there, I'll just hit it, close, and it is already attached to my mouse. All right. So after selecting, I'll just close. I'll see the voltage VDC was connected here and it was here. So let me see. As I said, that you have to hit the R key to rotate it. All right. But I remember when I explained you guys that this was in such a configuration. So plus here, I'll rotate, and plus was also here. Okay, I'll just put it here for the time being. All right, hit the escape key. Once this is done, just hit check and save. All right, check and save, just save your current working condition. All right, it's giving us warnings because nothing is connected. We're just putting the components, so those warnings are okay. So I'll go I'll look for the current source, because I know half an ampere current source was somewhere here and another 2 ampere current source was here in parallel with that. So for that, again, instantiate. Now instantiating a DC current source, I'll say IDC. All right, and we click in this space and the current source is now we can view the current source symbol here. All right. Now I forgot how the current source was. So it was from bottom to the top, and this one from left to right. All right. So rotate here. This is the first current source. Rotate from left to right here. It was somewhere here. All right. Once it is done, hit the escape key. So now we have pretty much all the schematic. The only last thing missing, without which your circuit is not complete and you're not going to get any points if you forget that, the ground. Ground sets the reference for measuring all the voltages and currents in the circuit. So we have to make sure that the ground is always there. You might not see in the schematics when you're solving your book problems, because the node with the highest branches is considered as the ground. But in this case, for example, we will look for the ground and we'll using the same strategy. This is the one which with most branches, and I'll choose this as a ground. And this is also defined within the, if you see, it is also defined within the circuit diagram, right? Where it is here, here's the ground. All right, so I'll go and I'll instantiate my ground. So instantiate I, and then I'll hit G and D for the ground. Yes, ground. All right, ground is here. I'll just put it over here. Okay, so once it is done, I will now start connecting the circuit. For connecting the circuit, you can either choose a wire from here. All right, create a narrow wire. All right, or you can just hit the W key. When you hit the W key, you will see your mouse has this wiggly line showing you that it is ready to connect the wires. All right, so I'll connect this point with this one with here, click, click, here, okay. We will fix this line later, you know, we can drag and fix these lines, not a problem. One, this is connected here, and then let me have a look. How is this connected? Oh, okay. Yeah, this line is connected all together, and then we have this one here. Okay. So this is connected here. It's connected over here. And as I see that this line is also connected here. The aesthetics and the beauty of the circuit will definitely come later. I'll make sure it looks nice and good. So this one is over here while this current source is connected here. Okay, let me have a look. I'll hit the escape key. Let me have a look if this is the complete circuit. So we have this line, okay, and these two are connected. All right, sorry. Let me just do it this way. Okay, then I can switch the windows quickly. So we have minus and plus here. We have a half ampere here with resistors, all resistors in this fashion, okay. And then this is the wire, this is the wire, and then okay, the circuit looks good. So what I want to do, I'll just go here, maximize the screen. I'll hit the F window to fit the circuit, all right? So it will just fit my circuit in that space. Now, if you look at this, by scrolling the middle mouse button, you can see that, you know, this wire is not connected. So hit the W again and just connect this wire, all right? What else doesn't look connected? Okay, this one also doesn't look connected, so I'll hit the wire and bring it over here. Okay, now let's just maximize this, fit the window, and let's try to fix how the circuit looks. So all you have to do is to drag the wires to make them look good. So I've dragged this. Okay, this looks good now. This one, drag back, put it here. All right, I will click this wire and I'll bring it here. Okay, all right, for this one I'll just do this. Okay, sorry, here. What else? I'll just put it in the middle somewhere. This one also a little bit middled. So actually I can drag the whole thing here. Okay. All right. The circuit looks okay. I'll just bring this thing down a bit, all of this line, and then I'll also so U for undo. If you want, if you have made some problems, just hit the U key. That is an undo. All right, a little bit down here. Okay, so this is the circuit. Once it is done, we have to go to the next point, which is labeling the nets. This is very important. This is the backbone of the system, that you will have to label the nets, label the nodes, right? So in this circuit, we were looking at this one as a V1 and this one as a V2. So I'll label these nodes. So from labeling, I'll hit the L key and it will take me to the pop-up window where I can label. And the cadence labeling follows the MATLAB rule. If you know how the vectors or matrix or arrays forming in MATLAB works, you can use the same one. So you can do V1 V2, and it will create two labels, V1 and V2, and it will ask you where would you like to attach these labels to. Now make sure that the V1 and V2, they are both small, because if you choose V1 and V2 as the capital, the block letters, you will see here the source has been labeled as capital V1. So if you try to label this node as capital V1 while this is the symbol for this voltage source, then there will be conflict and there will be errors. So that's why I'm just choosing small v1 and small v2. All right, so after this I'll just hit the close, and now here's the v1 and here's the v1 and here's the v2. Okay, these two nodes are now labeled. So once this is done, I'll hit the escape key and I'll do check and save. Okay, there are check warnings in this. All right, we'll look into the check warning. So the first two check warnings are here. I can see, you see they are highlighted, 1, 2, and 3. These are the 3 warnings. Let's see what are those warnings. To focus on these warnings and what they are, you will have to hit the G key. All right, or you can go to the view, and from the view you can go to the annotations. No, sorry, check. You can go to the check and find markers. So find markers means that these markers which are highlighted. So you can hit the find markers and it will tell you these are the 3 problems that they're facing. So what are the warnings? Warning says a solder dot on crossover. Second warning is also the same. Third warning is also the same. So there are solder crossovers. All right, what does that mean? So I'll click this one. Okay, I'll look into this one, solder crossovers. So for this one, I don't think that the ground is connected to it. So I'll just I'll pick up the ground and I'll try to connect it here. Okay, now it seems connected. I'll do check and save again. Okay, now 2 warnings are left. All right, as I said that you can go to the markers or hit the G key here. So now there are 2 solder crossovers. So there's a dot crossover here. Now what does that actually mean? Let me fit the window. What does that mean? Now the system is telling me that maybe there's a chance that you wanted this R1 to connect from here directly to this line over here. Maybe you never wanted a crossover here, all right? Or maybe you did not wanted a crossover here. Your intention was to connect this line of resistor directly to this voltage source. So it is just giving me a warning that just check. It's an ignore. I mean, I can ignore the warning. This is not an error. I'll look back to my circuit diagram. I'll see that actually no, my R1 and R2 is not connected directly to these lines. As you see, a resistor is indeed connected to these lines. So in that case, these are the warnings. I can ignore them. But if you don't want to ignore them, you can go to the check and go to the rule setup. All right, in the rule setups, these are the physical problems that we saw. Okay, so I'll click the physical and it gives me these set of warnings or errors that are there. So it is telling me that solder on crossover. So this is a solder paste on a crossover. Yes, if you see that, give me a warning, or I can make it as an error, or I can ignore it, whatever I like. The point is, this is not very important. I can safely ignore it. There's no point in making it an error. But if you're working with the large circuits, normally there could be a mistake when you're connecting a resistor. Just you see the line and you connect it, but basically maybe your intention was actually to connecting the resistor to this line. All right, for me this is a warning. I'll see if there are only 2 warnings, I can safely ignore them. All right, so my circuit is now complete. Now all I have to do is to provide it with the values. For the values, I have 2 ohm, 4, 8, 10. Okay, 2 ohms, 4, 8, 10. All right, so I'll click this first component and I hit the Q for the properties. It'll open the properties window. The default unit for the resistors is ohms. So if you want 1 kilo ohm, you have to write 1K. So that is the unit, and actually default value of the resistance is 1 kilo ohm. Since we need 2 ohms, so I'll just write 2. I will not type in ohms because that is a default value, and I'll just say okay. So now this value has been set to 2 ohms. This was, what was that, 4810? Yeah, 4810. All right, so I'll go here, hit this one, Q, and next time when you've set the values, next time the pop-up window opens and actually your resistor values will already be highlighted. You don't have to select this specific area. 4, hit the enter, click this one, Q, 8, hit enter, this one, Q, 10 ohms, hit enter. All right, then I know this was half ampere. I still remember that. Q, select the DC current, which is 0.5, and ampere is the default value. This is half ampere. This was 2 amps. I'll hit the Q, 2. That's it. As I said, ampere is the default unit. 2 amperes and half ampere. We have 5 volts and 12 volts. All right. This one, select Q. DC voltage is 5 volt is the default value of default unit, and this was Q, and 10. DC voltage is, no, not 10, wait, it was 12 maybe, yeah, 5 and 12, sorry, 5 and 12. So I'll hit the Q key again, and instead of 10 it will be 12. All right, so the values are now set. Once this is done, hit the check and save so that your schematic is saved. You still have those 2 errors. You can see these are highlighted here, these errors here, right, which is telling you that you have to look at these. You might never intended it. All right, fit the window. Now once it is done, you go to launch, go to ADXL, because now we have done the schematic. We'll go and launch the simulation. I'll go here, I'll create new view. Okay, for example 1, there's a cell, yes, and the view is in ADXL. Okay, this window will open. Welcome to ADXL. Within the test, go and click here. Yes, cell name is example 1. Okay, and within this, first, you have to go to the setup, go to the environment, and go to the run with 64-bit binary. This is very important to run your simulations properly. Go OK once you've selected it. All right, done. Now you will select within this window what kind of simulation do you want. As I said, that we will be doing a DC simulation or DC operating point analysis, where we try to solve all the voltages and currents and the power in the circuit. So this is the first tab, this is the second, third tab. I'll select the first tab. Within the first tab, I'll say transient simulation. No, I want DC simulation, and I'll say that, you know, save DC operating point. All right, save DC operating point. That's it. Once this is done, I'll say okay. So it has created this test. Okay, now I can close this window, and I will go here. If you don't see it here, I'll just extend it. Here's a simulation running, so I'll just hit it, run simulation. This is running a simulation. Okay, I cannot see any error. There's a warning. All right, and there's no error. So there's only 0 errors, 1 warning, and 4 notices. So 0 errors means our simulation has been completed. So what I'll do, I'll just right click here. I'll go to the annotate, and I'll say annotate DC node voltages or DC operating point or DC current. So what I'll do, I'll select DC operating points so that it will give me all the voltages and currents and powers into the system. So I'll hit it, and look at this. It has now given me the voltage and current and power at this resistor, here at this resistor, and here this resistor, these current, the sources and everything. It is now defined. So once the simulation is done, all you have to do is to right click and then go to the annotate. Within the annotate, you will hit the DC node voltages. Once you hit the DC node voltages, it will give you this 7 and 0, this is the voltage across this resistor. So here's this node is 7 voltage, this is 7, this is 7. So all those nodes which are connected together, they are at the same voltage. All right. Similarly, V2 as per the requirement was 12 volts. So this node, all these nodes should have a 12 volts. So let's go there. Yeah, V2 is 12 volt, this is 12 volt, and this is 12 volt. So this is the 12 volt. So we have now looked at all the node voltages. And as I said, that you can to annotate the circuit with DC operating points, you will be able to see all the voltages and currents and the power through the circuit. So one more idea was to look at the power of the 2 ohm resistor, which is this one, and the power of 8 ohms resistor, which is 3.125. This one is 0 watts. Let's have a look at this. Yes, this is 3.125. We can see that watts, and this is the 2 ohm resistor. This has 0 watts. Now we can see that this resistor had 2 node voltages, 7 and 7, which are both same, which means there is no current flow through the circuit to the resistor, and that means no current, which means no power. All right, so we can confirm that there is no power in this circuit. This is how you would create a circuit, and this is how you would run a simulation. Now for the lab delivery, please note that screenshots will not be accepted. No screenshots. Please make sure you take a note of this. No screenshots, no matter how high resolution they are. You will have to follow a proper method of exporting the schematic. So how will you do it? Let me go here. Okay, you will go to the file, and then you will say export image. All right, I want to export this schematic. All right, and then export what? Export selected area. So we'll select the area. Okay, let's select the box. I'll just put it here. Let me select the box. So all right, this much area is what I want for the selection. Here's the box. Sorry. Okay, now it is asking me scale exported region by 4 times. Okay, this is what you will be doing. These are the things that you will be doing. So I want you to do it 4 times, and then appearance is full color. Yes. For the background, please click the background and choose any of these light colors. It just enhances the text, and it's easy for me to look at the powers and voltages. All right, so select any light color from here. All right, you can select any light color. All right, but it should be a very light color so that I can easily observe. So normally what I do, I just click any color from here, and then I say that okay. Once it is done, say okay. And now I would like to save this file. Save to file. Which file? Now for that you will have to go back to your MobiXtream. In the MobiXtream, within the MFS11 folder, so this right now I'm at the CDS folder. I would go back to my MFS11 folder here, and within this I'll create a new folder. I'm calling it Advanced Circuits 2026 underscore pics. Okay, so that's what I'm creating. So you see that this is now created. All right, in the MFS11. So here I'll export. I'll say browse to not CDS. As I said, I went to the MFS11. Yes, this is the file we've just created. I'll select this folder to save the pics. Okay, it's there. Okay, now the name of the output file, sorry, what happened? Export, choose a file to which image will be saved. Okay, I'm choosing the file in this. Okay, it wants the name of the file, so I'll name it as my example. Okay, within the advanced circuits. Okay, in advanced circuits pick my example is the name, and you will see that it has written that my example name as a file name, and then I'll say save to file. Once you do the save to file, you can go to advanced circuits, open it, and my example.png is here. What you have to do is to right click, and you can say download here, download to my desktop. Here's my desktop. I'll say okay. You'll go to the desktop. Within the desktop, I can, oh, here my example is now formed. I'll double click my example, and you will see that the circuit diagram is now here. And I was choosing the white background because now I can make the text bigger, and I can still see all the text visible here. All right, so it's less straining the eye. It's not very much straining my eyes. So that's how your final image will be look like. So when you send me, I'll be able to zoom in as much as I want and without distortion, and this will happen if you'll do it for 4x. If your image starts distorting, I'm sorry, I'll have to deduct the marks, and there will be no negotiation over that, because I'm specifically teaching that, and there's a video, and there are the commands on how to do it for the Mac users. You will be able to do that too. So that's all from my side regarding these instructions on this lecture. I hope everything is clear. If you don't understand something, please write me an email. You'll have these two assignments. This is the example circuit I've drawn. Here are your two problems, just small practice problems. Make sure, as I'm asking you, I want the voltage across all resistors. Please make a table in the end. All right. You should make a table with 3 columns, for example, where all the resistors numbers, their voltages, their currents, and the power dissipated by the resistance 4 ohm only here. Similarly, you will do the voltage across all resistors. Please present your results in the table, as well as I want to see them in your circuit diagram, and I want to see all those values in the table. All right. These are again the notes on Cadence on how to go about it, how to log in for the Mac users. And please read these instructions. All right, you have to install exports. For the Mac users, this is the way to export the high resolution images. All right, this is an example from my circuit how to do it. This is the template where you will be using SCP, and your user, your NetID, and from local folder to your so from server to your local folder. I hope everything is clear. I'll see you guys again. Thank you very much.